Joining you this morning, Chris Smith, the naked scientist. And remember, you can call in, ask him any questions you like about things happening around you. Maybe you've got questions about something you've observed. Chris, great to have you back.
Morning, Keno. Now, we had homework last week, so lest we forget to hand in our homework, we should do that first, shouldn't we?
Yes, indeed.
The question related to tanzanite, didn't it? Because we were talking diamonds and carbon, and then we were asked about whether tanzanite and diamond are the same thing. Now, I said I would take this as homework because I wasn't exactly clear what's in tanzanite, and that's not unreasonable because I wasn't sure if tanzanite was distinct from the other gemstones, things like rubies and sapphires and emeralds. The answer is it absolutely is. Tanzanite is a calcium aluminium hydroxysilicate, whereas things like rubies and emeralds and sapphires, they are a form of aluminium oxide. Both of those classes of gemstones, of course, completely distinct from diamonds, which are purely carbon.
Now you see, therein lies the answer, Chris. You're always good at doing your homework, by the way. I'm going to have to give you a noddy badge.
Oh, that's good. Thank you for that. I have a gold star.
You will. Okay, some of the other questions that have come through this morning. Do mosquitoes prefer certain blood types? And if they do, how do we determine that?
Yep, mosquitoes definitely have a preference. It doesn't necessarily go with just blood type, though, but mosquitoes do have a preference for certain individuals. And we're getting closer to knowing what those various things are. The researchers I have interviewed in the past include John Pickett, who's a researcher at Rothamsted Research, and James Logan, who's at the London School of Hygiene and Tropical Medicine. They were doing research in the last decade where they took individuals and collected all of the smells coming off their skin and then presented those smells to mosquitoes in the form of a Y-shaped maze. So you have a glass tube and it splits into two arms, a bit like the letter Y, hence the name. And you blow the smell of a person in one arm and you have a neutral odour in the other arm. And you count, when you put mosquitoes in, how many of them go down one arm or the other arm. And by totting up this, you can therefore work out, relatively speaking, how attractive someone is compared to somebody else. When you start to see a pattern, you can then start to ask, if you do this enough times, what chemicals tend to be present in the smells of people who, on average, tend to be more attractive to mosquitoes or tend to be less attractive to mosquitoes. And there are various volatile chemicals that come off of the skin in some people which make them either more attractive or more unattractive. And the relative proportions of those that you have determine how attractive you are in total to mosquitoes. And it turns out, in my case, that I'm relatively unattractive to mosquitoes, but my wife, they love her. So it's great. Whenever I go out anywhere, I don't have to wear any mosquito repellent because they're all busy feasting on her. She's the biggest mosquito magnet, and I'm completely left alone. So that's the answer. It's not down to just what blood it is, because the mosquito doesn't know what your blood type is before it's drunk you. Whereas it can smell you. Mosquitoes have amazing senses of smell. And so mosquitoes home in on you using the sense of smell, using the CO2 that you breathe out, and they can also see and detect heat. So they use all of these things to work out where you are and home in on lunch.
We spoke to a doctor, a Cape Town-based doctor, who understands all these things as well, probably about 4 or 5 months ago. And she made the point that mosquitoes tend to try and bite everybody. It's just when they do bite you, you don't get that inflammation on your skin. Do you agree with that?
Well, no, because it contradicts what I just said, which is that we do know there are people in the population who are definitely more attractive, and there are people in the population who are definitely more unattractive to mosquitoes. The next stage is, well, when you're bitten, why do you then get that itchy rash? And the reason is that when the mosquito bites you, it does several things. It bites you, it's not strictly a bite, but it's threading in its proboscis, the thin mouth part of the mosquito, which it threads in through the skin, and it probes that into a capillary, which is where the blood is flowing through the skin, and its aim is to suck up a blood meal, because blood's got loads of protein in it, and the mosquitoes that bite are the female ones, and they need that protein and iron because they're going to lay loads of eggs to have loads of baby mosquitoes. That's why female mosquitoes feast on us and other animals. Now, when they put their proboscis in through the skin, it's very narrow and thin. It would be very easy for that to become obstructed by a blood clot. So the mosquito also chucks in some of its saliva. And the saliva contains various chemicals which are intended to do two things. One, they ward off your immune system and make the mosquito able to fly under the immune radar for a while. And two, they have an anticoagulant effect. But there are some freeloaders, and also going in with the saliva include various microorganisms. If you're very unlucky, that can include malaria, of course, but also there are various bacteria, things like Aeromonas and other bacteria that live in the mosquito, in the mosquito's salivary glands, on the mosquito's mouthparts, and fungi. They are added too. And your body's immune system, when the immune suppressing effect of the saliva wears off, and when the action of those microbes and the other proteins that they've put in, when your body then sees those chemicals, then it begins to react, and that's when you get the itchiness, which lasts for a few days. And that itchiness is inflammation, often led by histamine, which is there to bring in the immune system and get rid of the problem that it perceives, which is something trying to burrow through your skin.
Oh, that makes better sense to me, actually. So, Chris, why is it, and this is a question from me, Kino now, right? I never used to get bitten, but all of a sudden I am getting mosquito bites.
Maybe you've
And I
changed your
still wash
aftershave.
every day.
You changed your aftershave, or no? You're right, because and I know I said that in a slightly funny way, but it's actually potentially quite right that various soaps and other things, mosquitoes have amazing senses of smell. Their antennae are decorated in whole clusters of receptors. These are chemical docking stations for smell molecules in the air, and mosquitoes resolve across the two antennae the relative concentrations of these chemicals, and by flying backwards and forwards across the air, they can work out which direction the smell's getting stronger, and that's how they home in on it. And they are very sensitive to not just the smells of humans, but other smells we put on humans. There are various things that are added to perfumes and aftershaves, other colognes, for example, because some of these things have their direct origins in nature from animals. And so these are also potentially detectable by mosquitoes, and it may well be that some soaps, some aftershaves, other things are making you smell even sweeter to a mosquito. So perhaps you have changed your grooming technique, and this has made you more attractive to the mosquito.
Maybe I'll stop showering for the week.
No, don't do that. Don't do that.
No. Let's go to Paul in Durbanville. Hi, Paul.
Yeah, hi, Doctor. Okay, well, thanks for answering my Tanzanite question, but now I've got another one, but it's not a material question. It's sort of a double-barrel question. If the female mosquito is the one doing the biting and sucking the blood for protein, is it that her sole diet? And if it is, what do male mosquitoes eat?
Hi, Paul. The answer is no, it's not her sole diet, and it's not her sole diet all year round, because the mosquitoes only do this fairly high-risk feeding strategy, and it is higher risk because you're more likely to get squished when you're feeding on blood by the animal detecting you're there and splatting you, compared to if you do what mosquitoes do the rest of the time and what male mosquitoes do exclusively, which is that, just like other flies, they will go and find sources of energy in anything they can. Chiefly, they'll go for things like fruits. They use that powerful sense of smell to track down the smell of rotting fruit, and they land on the fruit and they suck up sugars from the fruit and possibly other nectars and things. But chiefly, they'll go for fruits and things. Sugar, lots of energy in there, nice watery solution, easy to draw up, a bit like blood. So they suck up the juices of fruits and things, and that's how they get their energy.
Okay, Paul, thank you very much for that question. Another one here. What is anger, and why do some people get more angry than others?
Anger comes in several forms, doesn't it? Including hanger. You ever get that? Do you get hangry?
No, hanger.
Well, when you get hungry,
Yes,
and then you get
yes,
really wound up because
yes.
you're hungry, and often we all deny we've got it, but then it's clear to other people that it's happening because they feed us, and then we settle down. I'm one of them. The reason we have anger is because it's a display of aggression. And all animals can display aggression, and they do this in order to stake their claim, to ward off things that might regard them as lunch, or to win mates. Because in nature, there's a huge rivalry between animals that want to be the father of an animal's offspring and other animals that also want to be the father of an animal's offspring. And it's all about your genes wanting to make sure they get into the next generation. So you need to have a degree of aggression in order to achieve those sorts of things. And in some people, they may have wired up their brain in such a way that tends to make them more aggressive. There may well be an aggression-prone personality. We know these people exist. Also, we know this is downstream of the hormone testosterone, because males, we were just talking about wanting to father the next generation, males have much higher levels of testosterone than females do, and the regions of the brain that encode these behaviours are sensitive to that hormone. So therefore, there's a hormonal influence as well. And then there's going to be an environmental influence. If you're in a situation where the surroundings are calm, everyone gets on, there's nothing in short supply, no reason to become ill-tempered or unhappy, then you're much less likely to learn to become angry easily than someone who lives in a high-stress, very volatile environment where they're continuously being niggled or wound up or having to look over their shoulder, which means that their level of anger tone is likely to be a bit higher.
You're listening to Dr. Chris Smith, the Naked Scientist, and if you've got any questions about everyday life and you're looking for that answer, he's the man to give you the answer. And if he can't, he'll bring back the homework and explain it to you. It's as simple as that. Now, here's a question which, baffles me. It says, can a transfusion change your blood type? Now, as far as I know, when you have a transfusion, you have to get a transfusion in your own blood type, right? Or do you?
No. And this is the rub. The blood types that we know about, they come in several groups. And these were discovered about 100 years ago. But there's blood group A, blood group B, and blood group AB, which is a combination of A and B, and then blood group O. People who are blood group O, what that means is that the surfaces of their cells don't have any chemical markers. The blood groups are because on the surface of cells are sugar molecules, which are like flags to the immune system. And if you're group O, O is 0. There are no markers on your cells. So if you're group O negative, which means you also lack another marker called the rhesus factor, you can give your blood to anybody, and because there are no markers on the surface of the cell that the immune system can recognise, those cells are like anatomical Teflon. They sneak around in the body and they don't get deleted by the immune system. They don't cause an agglutination reaction. On the other hand, if you're group A and you give your blood to someone who's group A, the markers on your cells say group A, and the antibodies in their blood are not group A, so those cells are fine in a group A person. But if you give the group A blood to somebody who's group B or somebody who's group O, they've got loads of antibodies against the A marker in their bloodstream, so they will immediately jump on those cells, glue them all together, and you'll get a thrombus in your blood vessels, and this can be lethal. So the answer is, if you're group O negative, everyone's your best friend because you're 15% of the population or less, and you can give your blood to anybody, so much in demand by blood donation services. If you're any other blood group, you have to be a bit careful because you've got to make sure that the right blood goes into the right person.
All I can say to that is, oh, got it?
Well done.
Let's go to Alfonso. Alfonso in Goodwood, good morning.
Hi, good morning, doctor. Just a question. You know, for example, you're in your vehicle, right? You're driving, and there's a little fluff floating around, or even and then it decides directly and it goes into your eye. I mean, if you look at the space in your vehicle, you know, it could go anywhere, but it decides directly into your eye. Or even when you smoke a cigarette, you know, and then the ash blows in the wind, and it goes directly into your eye. Why not anywhere else?
Well, the answer is it does go pretty much everywhere, but all the times that it doesn't go in your eye, you couldn't care less. And because your eye is A, really sensitive, and B, it really matters because it puts you off and distracts you, you notice. So this is a sort of confirmation bias thing where you say, well, it always goes in my eyes. It doesn't. It always goes everywhere, but the only time you notice, pay attention and remember it is when it got in your eye and made you uncomfortable or put you off your driving.
Okay, thank you for that one, Alfonso. And another one here. Is it true that wildlife around Chernobyl is thriving today?
Yes, there is an exclusion zone. There was a no-go zone that was created in the area which was thought to be at greatest risk of heavy contamination during the explosion about 1986, wasn't it, of the Chernobyl nuclear power station?
Yes.
And as a result, people were evacuated because the fallout in that area being very high, there was a risk if people continued to live and work and farm and eat things and breathe in dust from that area, they would continue to be irradiated. And we know that radiation exposure is a high risk factor for a range of conditions, including cancers. Some people refused to leave, and of course animals were not evacuated, and nature has taken over, and it's become a very interesting study area. A good friend of mine has been there at least once, and she's made some beautiful films from there. There's thriving wildlife. there are also some very elderly farmers who do still live there, some people who have gone back since, so it's not a complete exclusion zone. There are some very radioactive areas still which you are advised to steer clear of, and there is low level of background radiation, but it's not as terrible as people had initially thought. But because those areas of high-level contamination are there and they don't stand out and say, hey, avoid this area, there's loads of radiation here, you can't just walk around with impunity and just go about your business, because you would potentially blunder into some of these areas. But yes, for the most part, there is a lot of very good wildlife there, and it's a wonderful experiment in rewilding. What happens if you remove the human influence and let nature return? And so we're sort of seeing this longitudinal natural experiment taking place. So, yep, there is a lot of wildlife and trees and other plants and things growing very happily there, but there are still some very radioactive spots too, so it's not completely safe.
Just shows you how we operate like a virus. We go in, we deplete, we move on. Let's go to James in Easter Plant. Hi there, James. Good morning.
Good morning. I'd like to find out how high is the blue in the sky? Thank you.
How high is the blue in the sky?
What an amazing
Wow.
question. Thank you for that. Very interesting question, James. The answer is the sky isn't really blue, the sky just looks blue, and the evidence for that is if you look at the sky at night, the moon is white, the stars are white, so if the sky was blue, that light would be coming through something blue and it would look blue. It doesn't, it's white. So the sky looking blue is just an optical illusion. That optical illusion is caused by our atmosphere, and our atmosphere is rich in nitrogen and oxygen, and it just so happens that those are O2 molecules and N2 molecules joined by a triple covalent bond. And that bond, the length of it, is such that it's about the same size as the waves of blue light. Blue light is very short wavelength, red light is much longer. So when the light from the sun, which is a mixture of all the different colours of the rainbow, hits the atmosphere, and the atmosphere extends, getting thinner and thinner as it goes to about 100 kilometres up, then it begins to scatter the light. And when you look at the sky, you're seeing blue light coming from all directions. So your brain says, the sky is blue because I see blue light coming from all directions, so that thing must be blue. Of course it's not. It's light that's ricocheting around all over the atmosphere, being bounced about and scattered by the oxygen and nitrogen in the atmosphere. So you could say the sky is blue because the atmosphere is there. How big's the atmosphere? Well, we regard space as starting at 100 kilometres up. That's the Kármán line. So you could say 100 kilometres, but by the time you get to just 30 kilometres up, we sent a balloon up to the edge of space last year. We got to 33 kilometres. The pressure there was 4 millibar, so 4,000ths of the atmospheric pressure at the surface of the Earth. So I'd say that wherever the atmosphere is, the sky is blue. So 100 kilometres would be the absolute limit.
What a beautiful question and a great answer, Chris. And on that note, I trust you're going to have a fabulous weekend, and I'm looking forward to next week.
I am, and I haven't got any homework this week, have I?
No homework.
Yeah, it's going to be
done.
a quiet one for me.
The naked scientist there, Dr. Chris Smith.